dear friends! As you probably heard, new PC-3000 update has been released recently, and here in this lab we have a lot of questions how to use new options. And that's why in this video we want to make a quick overview of the main features and make a demonstration to show how to use them on practice. First of all, let me start the presentation. My name is Sergey Eiger, and I'm working in this lab almost 6 years. I'm a technical support engineer and also HDD instructor. And today I want to speak with you about very interesting topics. At first, I will discuss Western Digital drives, and I'm more than sure that new feature which I want to show you will be extremely useful because all of you were waiting for it a lot of time. I'm speaking about ability to unlock service area access on the modern drive without using the special unlocked board. After that, in the second topic, we will continue speaking about Seagate drives, and here I will also show you some interesting things which were added in Seagate F3 utility. And in the end of this video, my colleague George will proceed speaking about SSD drives. But let's start from Western Digital. Of course, you know there are a lot of different models on the market right now. Some of them related to the 3.5 drives, some of them to the 2.5 laptop drives. But actually, it absolutely doesn't matter for us because almost all of them are using shingled magnetic recording. That's why the challenges, the problems which we have working with such drives, almost the same. Just a quick reminder of what is the difference between classic drives and modern drives. On classic drives, data were stored in the tracks which are located with some distance between each other. This technology is called perpendicular magnetic recording. And on the modern drive, situation becomes different because it's somehow necessary to produce drives with higher capacity. That's why drives manufacturers decided to use shingle magnetic recording. And as you see, tracks on such drives are overlapped like shingles of the roof. Moreover, they are combined in the special groups which are called bands. Because if you want to read the data from such drive, it's not a problem as the reading element is very small. But if you want to change something, if you want to write something on the drive, drive should change the whole band. That's why such drives are operating similar with the flash, with the block of the data. And of course, because of that, the microprogram became much more complicated. Because visually drives stayed almost the same, and probably you will not be able to find any serious difference between new drive on the left side and the classic drive on the right side. And right now there are several well-known families related to the SMR drives, and they are Palmer, Charger, Spyglass 2, it's for 2.5-inch, and Vinisar, Caramel, and other drives which are related to the 3.5-inch. But what about the main challenges which we have? Of course, the first problem is the locked technological mode. So we cannot do anything with this drive without unlocking. Also, such drive has a very unstable firmware because there is a very high chance of second-level translator damage. And the last challenge is the encryption. The data on such drive is always encrypted by the CPU. And what will happen when you start such drive in the utility? You will get a lot of messages like, in this example, set drive locked, and service area will not be accessible at all. What was the previous solution? The solution was to use the special unlocked board to transfer the original ROM on it, and after that you were able to work with the service area. But even after using this special board, data on such drive were encrypted completely encrypted because the uh, encryption keys were located in the original CPU, so it was necessary to use the native PCB. And right now we have a solution which allows you not to use a special unlocked board anymore. Uh, the single thing which you should have in your lab in this case is some kind of external programmer device to be able to read and write ROM from the native PCB. So what are the steps of unlocking? First of all, you have to read the ROM from the native board. Then you open the utility and use unlock set option, which will patch the ROM. You save the patched ROM and write the patched image back to original PCB using the same tool which you used before for reading it. And after that, technological mode will be unlocked. You will be able to work with the drive, with the service area, and CPU will be the native one. Of course, that's why the data will be accessible in decrypted format. And in utility, you will not see any kind of error messages because technological mode will be accessible, and you will be able to do a lot of things. You will be able to do the backup, to fix the firmware problems, to use low responding solution, to check the heads, for example, or work with security options. And right now, of course, I want to show you the real drive for better understanding how to use this option in practice. So what I have as an example, it is Western Digital Palm drive, which is locked. And right now I'm going to connect this drive to the PC-3000 portable, starting the software, power on the drive, waiting for the ready state, run the utility, choosing the family, start, and you see that drive is locked. And even if I want to do the backup, of course, it won't be possible. So what to do right now? Right now I will power off the drive and will unscrew the PCB. So please give me a few minutes. So PCB has been removed, and right now I'm going to use this USB programmer to read the chip from the original board without resoldering. Give me some time, please. So I'm opening the programmer software, detecting the chip, reading it. As you see, ROM already has been read. After that, I need to save this ROM in bin file like ROM locked, for example. Save it. Then I need to go back to the Western Digital utility without connecting the PCB and press unlock set HDD. Here I have to open my previously saved ROM and press unlock HDD with service area access. So after that new ROM has been generated, I need to save it with a different name like ROM unlocked, for example. Save. Here is it. And the single thing right now I need to do is to write this ROM to the PCB. So I need to open this unlocked ROM image and write it to the board. So writing has been completed and I need to put this PCB back to the drive to see what will happen after that. Okay, it's ready. So I'm back the drive to the PC-3000. Closing the software, open PC-3000, power on, drive comes ready, I run the utility, selecting the family and starting it. And that's all. As you see, there are no any messages about set lock anymore. I can try to do the backup without any problems. I can work with the modules without any problems. And of course, if I want to open the user area, I will be able to see the data in decrypted form. So I think that you will like this option, and after that it's much more convenient to work with the modern drives. That's why we can proceed speaking about Seagate drives. I'm going to start PC-3000 portable, port 0. Let's open the software before power on the drive. Terminal is also should be connected, of course. Power on the drive. Drive has been already patched for unlock. That's why we send unlock command and start the drive. Actually, this drive has no any kind of serious problems. I'm just using it to show you what kind of options you can use in practice. And some of interesting things are related to the uploading translator to the RAM and uploading media cache management table to the RAM. Of course, such situations are related only if you have previously saved backup files. Yeah, so for example, if a drive has a damaged translator and there are no any ability to write, and you have previously saved correct native translator, it's possible to upload it to the RAM and get data access. But I want to show you different option which is related with media cache, and the name is upload write protection and exclude trim records from the media cache RAM image. Actually, as you know that Enabling write protection is quite important, especially in situation when you are not sure that heads are working well. Yeah, to avoid different possible problems, it's much better to disable the write protection. And what about trim records? Trim records, it is some kind of uh, area which is marked like 0, but actually this area can have the real data inside the media cache. So this is some kind of double action. You uploading the media cache and you blocking the writing ability. So right now I can show you that media cache has no extents. Actually, there are only two extents here. Yeah, and also I have already created a backup for this drive. Yeah, here it is. Also, I want to show you that right now drive is able to write. It's able to write. Heads are working well. And right now I want to perform this option to block the writing and upload the media cache previously saved in the back. So I'm going to the option upload. And here I need to choose the files where uh, I want to take them. Yeah, the first one is the disk firmware. It is the 20D or 20E system file, let it be 20D. And media cache table is of course 348 system file. And after that, I'm pressing OK and waiting the results. Let's check the log. Wait a little bit more. And you see that writing block has been implemented and media cache is also has been uploaded. So if you want to check media cache, we can send the command cu4 to see the extents, and you will see that right now a media cache has been successfully uploaded from the backup. If we want to check writing, we can go back to the opened system file 181 and put some new changes, for example. And let's try to apply them and refresh. As you see, it's not possible to write anymore. That's why we have successfully used this option, which should be very useful on practice. What else? Actually, there is also one interesting thing I want to show you using the different example. It also will be Rosewood, but Rosewood AF, a different family, because this option is not available for all families. Let's start the utility terminal. Power on, unlock, and start. Actually, the same story here. Drive is in good conditions. We have already created the backup, and let's try to open the ROM of the drive. And see how this menu was changed. I'm speaking about these ROM parameters, and as you can see, there is ability to work with the heads map. Of course, this option should be used very carefully, especially when it's not possible to perform head swap, when it's not possible to find the donor, because this option can be unsafe in some cases. That's why if you not feel confident about it, it's much better to contact technical support and ask to help. I want just to show you an example on this drive. Actually, drive is in good conditions. It has only 2 heads. And right now, for example, I want to change heads map to disable head number 0. So I'm using the new heads map like 0, 0. And press OK. Right now, ROM has been changed. We need to write it to the drive and see how it will possible, if it will be possible to read the data from both heads or not. It's almost done. So we need to repower the drive. And send unlock. Right now we need to wait a little bit for the initialization, because such situation can be is not native for the drive. Yeah. But right now drive comes ready state. If I open sector edit, I will be able to read sector number 0, but will not be able to read the last one, because it's related to the head number 1. Yeah, so if I want to create the new task, I will see how it works. I cannot wait until full head map has been built, because I just need to show you the ability to image. You see head number 0 is working well, and head number 1 is not working at all, because we have changed the heads map. And the last thing I want to show you today is also very interesting and useful. It's related with edit HDID editing. As you, of course, remember, some time ago we have added ability to work with time-limited error recovery mode non-Western digital, which helps to reduce error processing time. So right now, the same thing is available on Seagate Drive also, and to enable it, it's necessary to work with 93 system files. So when you edit HDID, you will see 2 additional fields here. The first parameter is related to the TLER, and by default, it could be disabled. So if you want to enable it, you should set some value here. Yeah, for example, if you set 1, it will be related to 100 milliseconds. Yeah, so the time which drive will process on each error will be 100 milliseconds. It's much less than it uh, uses by default. That's why using this option, it's possible to work with the physical damage drive much faster, uh, much faster and much safe. Yeah. So if for Western Digital we recommend to use 200 milliseconds, if you want to use the same value, you should set 2. Yeah, it doesn't matter if you use hexadecimal format. Yeah. Both of them are okay. And also you can reduce retry count, how many times firmware tries to read surface. So if you suppose the drive is in bad conditions, it makes sense to use some small count like this, for example. And also pay attention that in new version, it was added additional state of the parameter here, which looks like a black square. This black square means that to use parameter by default. Yeah, we may not know if it's enabled or disabled. So if you are not planning to work with this parameter, you may leave it as this, and after rewriting the system file, this byte will not be changed. Actually, that's it. I hope that you will like new options, new features, and of course, if you have some questions and some real cases when you need help, you're welcome to create their tickets on our new technical support portal, and we will help you. And right now, I'm ready to pass my word to my colleague George, who will speak regarding new updates in SSD. Thank you very much, and bye-bye.
Thank you, Sergey. First of all, let me introduce myself. My name is George Belikov. I am technical support engineer and instructor in ACE Lab. And in my part of presentation, we're gonna talk about the latest addition to the support list of our SSDs. It will be the PCI Express NVMe SSD based on Phison 5016 controller. But before we're gonna talk about it, let's discuss the internal structure of any SSD. So first of all, we have a different type of interfaces. It can be divided by SATA types and PCI Express types. Then CPU, RAM, and the NAND chips on which all the data is situated. We are talking both about SSD firmware and user data. So the main challenge, the typical challenge, firmware corruption. Let's imagine that the SSD's firmware right now is in a good state, so everything is working fine. In such situations, we can have a default SSD functionality. So data access is available, it is visible in operating system, it is visible in BIOS, full capacity is accessible, we can read, write, erase the data. So we can work with this SSD as normal, nothing special. But what are the steps of data recovery, or what things go wrong when the SSD firmware is damaged? So in such scenarios, default SSD functionality is going away. So data access right now is blocked. It is not visible or partial visible in operating system or BIOS. It has a partial capacity, and it is impossible to read and write. So nothing can be done with this SSD if you just connect it to your personal computer. It's like a that SSD right now. You can't work with them, you can't communicate with this SSD, you can't send any command to it, so looks like nothing can be done. But actually, there is a way. So what are the differences between standard mode and techno mode? Standard mode, it's like when you are just connecting your fully working SSD to your personal computer. So you can read the data, write the data, erase the data, nothing special again. So everything is working like it should. But techno mode is another story. So we use this mode to be able to communicate with the drive on a really low level. So this techno mode can be used for us to be able to recover the data from it. The key features of this mode are direct access to NAND flash without needing to chip off. Modern SSDs has hardware encryption, so chip off method is not a good thing in data recovery from SSDs right now. We can bypass the decryption on the fly by the controller. We have the access to logically damaged SSD. We can eliminate mix on the fly. It is a pretty common preparation steps on almost all modern controllers on SSDs and flash drives. So again, this thing can be done automatically on the fly. You won't be able even to notice it. We receive the access to SSD service area. We can bypass the password of the SSD when we are using technological mode. We can bypass the trim. It's like one of the most common issues right now with SSDs, trim command. And data recovery will take us only around 5 minutes when we are working with the SSD in technological mode. So how you actually work with them, how you can deal with SSDs that are not working completely fine. So the first thing is shorting in safe mode. All the SSDs has a special shorting points on their PCB. Depending on the manufacturer, it can differ. So to be able to find these shorting points, you can use our software. Just pick the needed SSD and you will see the photos of it. If you didn't find it or didn't know how to do it, please contact technical support, create a ticket, send us a photo of your PCB of SSD, and we will guide you, we will show you the shorting points. So first thing first, to short the shorting points and to put SSD in safe mode. So we are doing it to be able to upload a loader inside the SSD RAM. So loader is a special microcode that has been written by our developers that helps us to put the drives in the techno mode. After we upload the loader, we receive the access to NAND chip, and right now CPU is working in a single channel mode. SSD is using a custom translator that we gonna build automatically after we finish working with the SSD before we create a new task in the data extractor. After putting the drive in the techno mode and uploading the loader, extended capacity is available. So there are no problems with the capacity like before, like zero capacity, 5 megabytes, 1 megabyte of capacity problem, something like this. Trim is disabled, so you should not worry about it at all. And the service area is unlocked. So working with the drive in techno mode provides us the ability to fix all the issues that can be inside the SSD. And the key feature of this is that all of these things will be done automatically. So we just need to press a couple of buttons inside the software to be able to recover the data. And in a couple of minutes, I will show you how actually easy it looks like and how fast you can recover the data even in the most complex SSDs. So, talking about the latest addition to our support list is of course Fusion based PCI Express 4.0 GAN NVMe SSD controller. So this Fusion controller was the first PCI Express 4.0 SSD controller. It was really popular. It stays the only PCI Express 4.0 solution from the middle of 2019 till the end of 2020. So a lot of people bought it, a lot of people use them every day, and a lot of cases should be faced soon because of this. Why people like this SSD so much? Because of the speed. It was a really, and it's still the really fast SSD. If we compare the speeds, the speed of reading is around 5,000 megabytes per second, and almost the same for writing, around 4,400 megabytes per second. If we compare it to SATA speed, which is around 500 for reading and writing, we can see how much faster newest SSDs are. And even if we compare them with not so old PCI Express 3.0 NVMe drives, which has the speeds around 3000 megabytes per second and 2,500 for writing, we can see that still latest PCI Express 4.0 drives are a lot faster and a lot more comfortable to work with. But it's still not a problem for PC-3000 tools with extended SSD support. So right here I prepared for you a SSD based on Fusion 5016 controller. It is the Apacer modification, and to be able to find the sorting points, you should look at the picture right here. So in right top corner you can see two sorting points. Just use a common tweezers, put them inside these holes, and you're ready to go. You shorten the drive, you put it to the safe mode. We suggest our users to permanently shorten the drive. It is a lot more easier to work with. But if you are not sure in it, you can use the pretty common tweezers, and it should be okay as well. So before going to the actual real-life case, let me just say it one more time. With extended SSD support in PC-3000 Portable 3 tool, you have a full support of SATA-based SSDs with the following interfaces: SATA, mSATA, Apple SATA Blade, M.2 SATA, and even Leaf and ZIF SSDs are in a support. We are the world's first and only tool who can work with physically damaged SSDs based on PCI Express interface, like M.2 NVMe interface, PCI Express NVMe and AHCI for like Apple MacBook SSDs. And we can even work with a really complex server SSDs with the interface of PCI Express X16. On the left bottom corner you can see a couple of adapters that you need to connect to be able to work with PCI Express drives, or the mSATA, for example, if you needed to. So I guess it's enough of the theory, and right now let's move on to the real-life case. And to do it, I need to connect this adapter with the SSD on it to port 0 on my portable. Please give me a second. So it is connected right now. And let's just open the software. As you can see, it automatically detects that we are working with M.2 PCI Express SSD. Let's imagine that we don't know the type of it. We can press the detect button here. It will show us that this is the NVMe type. Just click OK here. and wait a couple of seconds for initialization. So this is how SSD part of our software looks like. It looks almost identical like a hard disk drive part that was shown by Sergey. So let's power on the drive and let's go to the universal utility first to check the behavior of the drive, to check if we even have the ID of it. And as I showed you in the beginning of the presentation, one of the most common problems is ROM capacity. So this drive has some issues, and in universal utility we won't be able to do anything. In such cases, when you see such behavior, you need to go to the special active utility for your particular controller. In our case, this drive based on Phison 5016, Apacer is the modification of it. So we can press Apacer here, find out that we have the NVMe Phison, double click here, select the needed controller. As you can see, we support a couple of others as well. Pick the needed family and press utility start button here. As you can see, I already put this SSD in a safe mode. Let's wait a couple of seconds for initialization. And right now we need to perform a loader uploading. So loader is a special microcode that provides us the ability to work with the SSD in Techno mode. As you can see, all of this has been done automatically. Depending on your modification, loaders can differ, but they should be applied automatically, so you don't even need to think about it. We need to wait a couple moments until we see the next thing in the log. So as soon as we receive the information about the chips, about chips ID, type, vendor, capacity, how many channels, it means that the uploading of the loader is over. It has been completed successfully. We can see the full capacity of this SSD. So right now we are ready to create a task in data extractor. So let's name it like this, Apacer NVMe PCI Express for recovery. We need to select the active utility because right now we are working with it. Press next here. Don't forget to make a data copy. Pick the destination device selection. If you need to put some information regarding this case, you can do it. It depends, it's up to you. It depends on how many engineers working on it, for example. So we can just press OK here. And right now you can see a window of translator initialization and translator creating. So we can create a new profile name for this case, Apacer NVMe. Press OK here. So right now our software scanning the internal structure of the SSD, is scanning its blocks, it's trying to find if there are any issues, it's trying to find the information about the file structure, and so on and on. So you can see tables are being checked, field blocks reading is in process right now. So in most cases, it should not take more than 5 minutes, but depending on the capacity, depending on the chip's state of your drive, I mean physical chip state, as you know, modern chips inside the SSDs can have a lot of issues even from the factory. So it's not a new problem, it's the same as in flash drives, the same issues are in SSD's world. So do not worry if your translator building takes a little bit more time. You should always wait till the end. After creating a task, we can go to the Explorer window right here. And let's try to open the file structure that should be built right now in front of us. So we can see that it has the NTFS file system, so we can find the file structure without any problems. Root folder is here. Depending on the needed folder, we can save some of them, we can save all of them. But before saving, let's check what's inside. Let's try to open some folders. Oh, looks like there are a lot of images. It's a good demonstration to check if there are any corruption or something like this. We can open some of them to be sure. So looks like there are no corruption or anything. It looks like we can save the needed data without any problems. We can export the file structure to the forensic format if we need to. It depends on us. So this was the demonstration of how we can work with the latest addition to our support list. Don't forget that it is a really complex controller, but still it took around a couple of minutes for us to recover the data from this case. Of course, it looks easy, but it's all because our developers did a tremendous job. They created the utilities for each controller. They go through the internal structure of a lot of SSDs to create such utilities that you need to press a couple of buttons and data is in front of you. So let's say thank you to our developers. For this case, it's over, so let me just come back to the presentation window. I need to remind you that this demonstration has been made with PC-3000 Portable 3 SSD system. As I said, the world's only tool that can work with physically damaged NVMe drives, PCI Express drives, and it's not only for the SSDs, but with this tool you can work with almost all media storage devices that can end up on your desk, not only for data recovery, but for diagnostics, creating reports, and so on and on. So almost all daily cases can be solved only with one tool, no matter how difficult the case is and no matter what interface you are working with right now. But again, depending on the case, we have a lot of different solutions. So regarding the amount of cases, you can pick the needed tool that will be suitable for your forensic or data recovery lab. Thank you for your attention. Visit our website, visit our technical support portal, visit our YouTube channel, and if you have any questions, please write them in the comments. I hope to see you soon. Stay safe. Goodbye.